Okay, folks, please get your notes out. We are doing lesson 11.3. This is part 1. Tomorrow we'll do part 2. But we are talking about limits involving infinity. Okay, limits involving infinity. Now, we talked about the day that we had the discussion on if real life quantities had a limit or not, when we talked about how high an airplane can fly and how many colors do you think you could actually make, and that discussion, we did talk about infinity a little bit. The things that are not limited involve infinity. Like we talked about the amount of numbers in between 0 and 1 on the number line. That is an infinite limit. Or that's not an infinite limit. That doesn't make sense. That is the answer to that is infinity. There are infinitely many numbers between 0 and 1. We're going to talk about a lot of infinity today. So first of all, I want you to realize about infinity. Calculus and infinity get a little bit weird because infinity, first of all, is not a number. It's actually called a designation. Infinity is a designation of behavior. Okay, that's weird. It's kind of a weird word, but let's go with the fact that infinity just describes behavior. Okay, go ahead and have your sub pause the video at any time if you need extra time, if I'm talking too fast and you need more time to catch up. So infinity describes behavior. And so we will use infinity in 2 places. So remember when we talked about limits, usually there's a number here under the limit. So our infinity could go here, or our infinity could be the answer. So we either need we need to talk about x approaching an infinite thing, and we need to talk about how do we know when our answer is infinity. Now, listen, all the things that we've learned before still apply. Don't ignore them. They all build on each other. I think calculus is probably the math that builds on itself a whole lot, more than the other ones. The other ones are a little bit more pockets of things go together. Calculus, don't forget what we've already learned because we're going to continue to build on it. So 2 things before we talk any further. Like when we talk about behavior, we could talk about x approaching positive infinity. Think about a number line. Is that right or is that left? If x is approaching infinity. Okay, hopefully you said that it's to the right. But x could also approach negative infinity, and that just means left. Okay, so this infinity is representing, I said it describes behavior. This x is getting very, very, very large. Okay, so we just say this infinity. This x is getting very, very largely negative, which would be all the way left on the number line. So we're just using it to describe behavior. So grab your graph paper that you have. If the sub still needs to pass it out, then you can pause it and wait a second. So we're going to still talk about left-hand limits, right-hand limits, all the things. So let's do 1, 2, 3, 4. I'm going to number this. This is 4, 5, 6, 7, 8, 9. This is 10. This is -2, -3. That's -4. There we go. So notice that the places that I'm numbering are those places with vertical asymptotes. So horizontal asymptotes we'll get to in a second, actually. So you got a horizontal asymptote in both of those places. So I know, I don't remember which class it was, but somebody asked me about horizontal asymptotes, and those, I said, we do get to those. Can't remember what class. So let's do the limit as x approaches 4 minus of f of x. So our graph is f of x. He's not labeled as such, but we'll label him f. Okay, so the limit as x approaches 4 from the left. Remember that you pick 4, and it's been a while since we've done graphs. You pick 4 and you go to the left of it and you start going toward 4. Well, this guy goes up. Now, with the asymptote and that behavior there, we know that this guy will never stop going up. That's what's true about an asymptote is that as you go up, as you get closer and closer to 4, the graph continues to go up or down as the case may be. That's what creates, or that's what makes it a vertical asymptote. So what are we looking at his behavior? He just keeps going up. And so we can say that the answer to this is infinity. Okay. The AP College Board people are really picky about this. So we probably would want to say this is, we don't want to put an equal sign. We want to just put an arrow like that. It is infinite. Something cannot equal infinity. It feels like it's picky. And it's going to feel like I'm changing my mind when we get to tomorrow. But in general, you cannot equal infinity. So give yourself a little arrow. It is behaving that it is going up. That's what we write. If it's behaving as it's going up, large positive numbers, we put infinity. Anyway, so why don't you try the limit as then x approaches 4 from the right of f of x. Okay, so we're here coming from the right. Look at the behavior of this graph. What is it doing? It is going down. And so if it's going down, then we are going to write negative infinity. Because what's happening? Those numbers are going to get infinitely largely negative. Okay, that's what happens. These are y values. They're getting big down here, right? That's like -6, -7, -8, -9, -10. Goes all the way down and just keeps getting largely negative. Okay, why don't you try then, without me, the limit as x approaches -4 from the left, and the limit as x approaches -4 from the right. So you can pause the video, take a second. When you're ready, go ahead and pick it back up. Okay, unpaused. And from the left, this guy's going straight up at 4. You can see it, he's going up. Also from the right, this guy is also going straight up. So both of these are not equal to, they're arrows, right? Those are both equal to, I keep saying it. Those are both infinite, okay? So this limit does not exist. A limit only exists, this is what's weird. The limit is non-existent because this is never getting anywhere. Okay, this guy here, you can see him better on the graph. This guy's never getting anywhere. He just keeps moving and moving and moving. That's why we're not using equals, because it's not actually equaling any number. But it is behaving in a way, and so we can describe its behavior. Why don't you try the limit as x approaches 10 from the right and 10 from the left. Okay, go ahead and pause, take a second, and do that. Okay, when you unpause, here we are from the right, coming toward 10. This guy's going down, so his behavior is negative infinity. And this guy from on the left side is also going down, so his behavior is negative infinity as well. Now, what I want you to do is pause a second, check around, see if anybody has any questions. It's not a chance to talk. Like about random crappy things. It's just like look around and see if the people around you have questions. And if somebody around you has a question and you understand, please help them understand. So pause a second until everybody feels pretty good about their questions. Okay, now this goes back to what we were talking about Friday, with finding limits from left and right side. So can I say that the limit as x approaches -4 of f of x is something Okay, if its left and its right are the same, then I can say that this guy behaves as though it is going to infinity. Okay, anybody that understands horizontal, that understands this will go, oh, this is a horizontal asymptote and both sides go up. It's implied by this statement that both sides go up because I can't say this without the plus minus. Okay, I can't say it without the right and the left hand limit unless those agree. Okay, this guy, 10, the limit as x approaches 10 of f of x, they both agree. So I can say that the behavior is that it's negative infinity because they are the same. So when right and left are the same, then there is an overall, I can make a statement about the overall limit. Okay, now look at the behavior of this on the graphs. These guys both go down. So I'm just saying the same thing over. If they both go down, then I can say that the behavior of both of them is negative infinity. And this x approaches 10 without the plus or minus implies that I'm talking about both of them. Okay, here's the -4. So this guy, they both go up. So I can say the limit as x approaches -4 is infinite. Okay, it's infinity because it's behaving that they both go up. But look at x at +4. Okay, so here we're at this horizontal asymptote. The limit as x approaches +4 of f of x. Look at right, look at left. Okay, sorry, there you go. Left, right. And say those two things are not the same. So this limit does not exist. Okay, they have to be going to the same place. The right and the left have to be the same in order for the limit to exist. Okay, we talked about that. We've talked about that over the last week. Okay, so that's the basic idea of when your answer wants to be infinity, you're describing its behavior. Is it going up or is it going down? If it goes down together, you can have an overall limit of infinity or negative infinity. If they don't behave the same, so you have this asymptote where one is up and one is down, whichever way it's got, whichever way is up, whichever way it's down, doesn't matter, then the limit does not exist. Okay, so just let me make sure you're understanding me. Let's say this is my deal. Let's say this is 1. And this guy looks like this. And I asked you for the limit as x approaches 1 of f of x. Overall, sorry, we'll move it up so you can see it. X, y. This is 1 right here. That's the 1. Overall, limit as x approaches 1, I can only write an answer if they behave the same. This one goes up, this one goes down. This does not exist. I still can ask you to do the limit as x approaches 1 from the left or the right. So I'm only looking at half of this. So from the left, it's going down. So my answer would be negative infinity because it's going down. Okay, so pause a second, talk to the person sitting next to you and see if they have any questions about when they can put infinity as an answer or when they need to put does not exist. Okay, please summarize that for each other. When you're done, go ahead and unpause. Okay, now there can be a whole lot of vertical asymptotes in a graph, which means I have a lot of options for writing. I could potentially have a lot of options for asking you questions. There are only 2 options for the other one. So if I wanted to say the limit as x approaches infinity of f of x, there's only one place where x approaches infinity in any graph, and that is always right-hand side behavior. So what I do, x approaching infinity means x is very large positive. So I go all the way to the positive side of my graph and I describe the behavior of the y's. So remember that the answer here is a y value. Okay, and so the other way you could think about this is its end behavior. Okay, but you look at this and you go, okay, what's going on here? If I'm all the way out as far right as I can go, that's what this means, as far right as you can go. x approaches positive infinity, as far right as I can go, what's happening to my y values? They are getting close to 0. Okay, so then I can say that 0 is a number, so I can put equals. That's okay. That's all about limits, right? Limit doesn't have to be equal. It's just how it's behaving close to that. So this guy, we talked about horizontal asymptotes way back in chapter 2. This is a horizontal asymptote at 0, but we describe or define a horizontal asymptote actually has a limit in it. So the definition of a horizontal asymptote is that its limit as x approaches infinity is that number. It's definition of a horizontal asymptote. So the only other thing, this is my only one option here. The only other thing I could ask you is x approaches negative infinity. So this would be far right if I did positive infinity. And if I ask negative infinity, I'm looking for the farthest left. Okay, so I'm going to follow my graph out here. I'm going to go as far left as I can and look at what's happening to this graph. He's obviously leveling out. It is a horizontal asymptote, and it's looks like I meant it to be about 2. Okay, so 1, 2 is its y value. So I say, okay, this is a horizontal asymptote at 2 on the other side. There's no other options because I either go right or I go left, but there's nothing else. Okay, these are horizontal asymptotes right here. Horizontal asymptote at 0 for the first one, horizontal asymptote at 2 for the second one. So there you go. So let me give you this one. Okay, this is the last example. This is a pretty short lesson. Okay, so let's have this. First of all, do you know what family of functions that comes from? It's Tuesday morning. Either you're all dead or somebody knows. This is an exponential function. Okay, so let's do the limit as x approaches negative infinity of f of x. Okay, limit as x approaches negative infinity. Follow this down. If you were to graph it, I'm sure somebody in this classroom right now is like, this is not a very good graph. It looks like it goes below the x-axis. Fine, you don't like it, graph it on your calculator. Y equals 2 to the x, we'll just say. Okay, but if you look at it, it just runs along the x-axis. It has a horizontal asymptote at y equals 0. So the limit as this guy approaches negative infinity out to the left, this guy just runs along the x-axis forever. He never goes to the bottom and he never equals 0. Okay, that is a horizontal asymptote. Now, the only other combination you could have is something like this. The limit as x approaches infinity of f of x. So limit as x approaches infinity means I'm going as far right as I can go. So start following the graph right. And what's happening to it? It's going up. So his limit or his description is infinity with not an equal sign because it's not a number. Okay, so I can have an infinity in both places. That's weird, but it's just describing behavior, right? As I go out to the right, what's happening? It's going up and it doesn't go down because that's not the kind of function it is. Okay. I don't want really to give you anything else because beyond this, we get into some weird doing math with infinity, and that's, I think, best saved for in person, but I think you'll be okay with this. So the sub has homework for you. I'm not canceling anything out because it's going to take you like 3 minutes. Please be good when you are done with the homework. I trust you. You're not a freshman, so that's good.